Hi, this is Chris Schomburg, and today we're going to actually look a little bit into a transistor and how it works. Now, a transistor is a type of device that actually, specifically the NPN transistor, can actually amplify a signal. Now, it's not going to amplify it that large. It's not going to be a huge amplification. What we really mean is if we have a current coming in, we can actually get a higher current from that current. We can actually amplify or increase that current in a different segment of our circuit. Now, particularly when we're looking here, we're actually going to be looking at the base current, the collector current, and the emitter. So basically we have in an NPN transistor, there's a base, a collector, and an emitter. Now, it's really important that you note that the PNP and NPN look identical, but they're actually doped differently. So they actually have, what I mean by doping is that they're actually, when they're manufactured, they have either holes, positive charge, or negative charge, electrons, and how it's actually put together is different depending on if it's PNP or NPN. Now we're going to be looking at the NPN transistor, okay? Now, keep in mind that the NPN transistor is the NPN transistor is a 3904. It looks like this. We want the flat side out. We want the round side with nothing connected to it, okay? So we want the flat side out. We want to connect to the flat side. That's the NPN transistor, and it's a 3904. So the goal of this is to actually see that the collector current is actually larger than the base current. That's our goal. So in the end, we should see that the collector current, which means is larger than the base current, which is controlling the larger current. So both of them are tied together, but the collector current is larger than the base current. Okay, that's the key point. For this lab, you're going to need a breadboard, an NPN transistor, 2 LEDs, 2 resistors, a slide switch, and a 9-volt battery. So at this point, I think we have all the components we need. Okay, so I'm going to scoot this all over in a second here. Okay. Did one too many. There we go. Okay, we're going to put the meters right down here for now. We'll look at them later. We're going to put the resistors a little closer over here. Put the LEDs right here. Okay, we're going to take the NPN transistor, put that right there. Now, I'm going to actually make this small in a second here. But first, I'm going to go ahead, I'm going to pull up my diagram. Okay, this is something that I built a little while ago. Okay, so then let's go ahead and minimize this. And we're kind of going to do a split screen. We have the assembly drawing. We could do it from that, or we could actually do it from what I've kind of worked out. I think that's the best way to go ahead and proceed. Okay, so the first thing we're going to do is we're going to hook up both the positive and the negative rail. And believe me, it makes a lot more sense to go ahead and always use the positive and the negative rails. So I'm going to go ahead, I'm going to hook up the negative rail. I'm going to go to black. I'm going to hook up the positive rail. In this case, I'm going to hook it up like that. And we have the negative and positive rails. Now, the next thing we're going to do is we're just going to follow the line. Now, this is a 220 ohm resistor, okay? This is a 1K ohm resistor. I'm going to discuss, we're going to put them in the way they are, and then I'll kind of discuss why I think this is not a good idea. So the first one is a 220 ohm. Okay, the reason I don't think this is a good idea is because basically now what you're doing is you're comparing something. You're supposed to compare the base and the collector, right? And the problem is if you do that this way, they have two different resistances. And so by comparing them, you're already comparing something that is not apples to apples, it's apples to oranges. So that being said, I'm going to put them to start out with at 220 ohms. Just to start out with. So both of them are at the same level. Now we're comparing apples to apples or oranges to oranges. That is much better, in my opinion, than trying to compare something that is not even the same resistance. Why? Because if we compare them, if it's a low resistance, right, it's going to be brighter, right? It's going to be more like a short circuit. It's going to be a lot brighter. The electrons are going to flow a lot faster, or not faster, but just it's going to be more brilliant. If we have a really high resistance, it's not going to be as brilliant. So the LED is not going to be as brilliant. So that's kind of a key point. Okay, remember the round side is always the positive side. The negative side is always the flat side. Again, the positive side is the anode. The cathode is the negative side for this. Okay, so what we're going to do then is we're going to hook in. The next thing we're going to hook in is we're going to hook this down here, and we're going to go all the way to like 17. Now why I'm going so far down is just so that I have space to do this. I'm going to then rotate my NPN transistor, and this is going to go to the very end, so this is going to the emitter. Okay, so this flows through the positive, through the resistor, through the LED, and then down to, in this case, the emitter. Okay, that's what we want. Okay, so the next thing we're going to do is we're going to go ahead and I'm not going to follow this logic from the NPN transistor. I'm going to follow the positive logic. So I'm just going through here. So this is the high signal going through resistor. We're going to need to go through another resistor. We want those to be the same. Okay. Of course, this is inconvenient. It's at the same spot. What it's telling me is at the same spot as where the resistor is. Okay, I'm going to have to maximize because this is being silly. There we go. Alright, so I'm going to go ahead, I'm going to put this down. I'm going to leave 2 spaces and I'm going to just put it down to that. Okay, now. Okay, so now what we can see is, we have a positive going into the next resistor, comparing apples to apples. There are 2 of the same ohms resistors. Okay, and then what we're going to do is we're going to go to a jumper. Okay, so this is going to jump. I'm going over here, and then I'm going to put in the switch. I'm going to rotate this switch. Okay, and we can put this switch, and put it all the way on the other side just so that we can see it. Okay, so now I usually make these blue. This actually is a high signal, so actually, but it's after a resistor, so after a large drop, so I'm making it blue because it's probably after a pretty large drop there. Okay, now this is actually it's jumpering, so I'm going to actually put it right here. I'm going to make this turquoise because it's going to be a little bit less, but not that much less after the switch. Okay, so then I'm going to go ahead and I'm going to put in the second diode here. And again, we want the positive lead at the top. So we're going to want the circle or the anode, and the negative lead or the flat lead on the bottom. So we're going to set that right there. Okay. Now, we know that we're in 12 right here. Okay. So what we can do is we could go down the same line, but I don't like doing that. So I'm going to go down all the way to the end on F12. Okay. And then I'm going to go down to my center point of my NPN transistor. Make this purple again. So this is blue, then turquoise, then purple. And we're going to the center point of my NPN transistor, that is the base. So we're comparing the base. Now we're going to go from the base all the way to ground. Okay, that's just really simple. So now we have two lines coming in. Okay, so now we should have power coming in, going through the resistor, the first resistor right here, right? It's going through that first resistor, then coming out, then going down to the NPN transistor, to the emitter. Okay, we'll stop there, that logic there. We're going to then go from the other power, we're going from here through the resistor, dropping down, we're going through the switch, okay, then through the switch to the LED, okay, and then to the positive end of the LED, then to the negative end of the LED. From the negative end of the LED, we're going to the base. Oh, we did this wrong. The one thing that I'm seeing that we did wrong is that this is correct. The purple's correct. It should go to the base. But the black line is that actually not going through the base. It's going from the very first line. Okay. So it's going from the collector. Okay. Now let's compare and just see that that's true. So if we look here, right here, this is our collector from the NPN transistor. It's going, if we look back, and we're going to maximize this, it's going to go to ground, and that's the ground pin. So that looks correct. Everything looks good. Let's go ahead and start the simulation. Nothing should happen to start out. If we switch this on, we do see this. Now this is kind of nice about Tinkercad, is that we can actually, if it's over, we can click it and say this one right here is saying that there's 30.7 milliamps, while the recommended is 20 milliamps. Now it's not recommended to burn out LEDs. Don't get me wrong there. But it's nice because it's telling us a reading. Because normally I would put in multimeters and check this, but we can see this is 30 milliamps. Okay, and this is from right here, which is the emitter. Okay, so that's 30 milliamps going through the emitter. Okay, if we look, this is the base. Sorry, the base is 27.3 milliamps, and guess what? The base is a lot lower current than the collector current.